All right, chapter 14. Okay, so these are some scores on a Chem 103 test. How people do. So basically, the first what we're gonna do is we're gonna talk about. So the chapter 13 was all about how do you wisely gather information, right? What are smart ways and not as smart ways to gather information, collecting information. Now it's about how do you display information, like how do you communicate a whole bunch of data all at once? How does that work? So for example, if I wanted to communicate to some class, what if this was my chemistry class, my Chem 103 class, and they asked, hey, how did the class do as a whole on the exam? How do you communicate that? How do you talk about how a group did as a whole? Should I just read all the numbers? Should I say, okay, you guys want to know how you did as a whole? There was 100, 90, 80, 60, 60, 80, 70, 70, 60, 190, and blah, blah, blah. Just read them all. That wouldn't work for anybody, right? We human beings don't work well that way. Just hearing a whole bunch of numbers read off, that doesn't do anything for us. So basically, this whole chapter is different ways to describe a bunch of information, information, data, all at once. What are the good ways to do that? One of them, starting most simply, there's what's called a frequency. This is a frequency table. And it just simply means you list how frequently, how many times, the different things happen. Like how many zeros are there? I don't think there's any zeros, are there? No. No zeros. Frequency 0. How many tens are there? There's no tens, are there? Oh, there's one. That's too bad. 10. Yeah. There's 1. So there's 1 10. I'm just saying how many of those scores there are. How many 20s are there? 1. I'm going to cross them off as we go. Just 1. 120. How many 30s are there? No 30s, right? Yeah, none. How many 40s? Are there any? I don't see any 40s. How many 50s? Oh, we got a lot of those. 1, 2, 3. Just 3, I guess. 3 50s. How many 60s? 1, 2, 3, 4. 4 60s. How many 70s? 1, 2, 3, 4, 5, 6. How many 80s? 1. How many 90s? 1, 2, 3, 4, 5. And how many hundreds? 1, 2, 3, right? That's it. That's all they want, first off. So that's called a frequency chart. You just list the various scores and you say how many. That would be more helpful, wouldn't it? Somebody said, well, how did we do as a whole? And you put that on the board. They know, oh, yeah, 3 people got 100, 5 got in the 90s. Yeah, that'd give you more of a feel for the numbers as a whole, for the class as a whole. That's one of many different ways which we're gonna see. All right, I'll move along. You stop me if you have questions on this. Okay, so same kind of thing, Chem 103, there's the scores. Now they're saying, all right, how many got in the 80 to 100 zone? How many got A's and B's, basically? And so it's the same thing. We're doing the same thing. You just check them off, right? How many 80s and 100s will be? 1, 2, 3, 4. I mean, it says it's 8 over there. Are there 8? 4, 5, 6, 7, 8. Yeah, I guess there are. So that's why we have the number 8. So 8 got in the 80 to 100 zone, etc., etc. Make sense? On that, that's just another way to do a frequency table where you put them in different groups. All right, then part B, make a bar graph. Now, how do you make a bar graph out of the information? I'm just going to make it right here. So to make a bar graph from this information is basically to make the frequencies become the heights. The frequencies are the heights. So you have a height of 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's 8. So the first bar comes up to 8. That's the 80s, 80 to 100 bar. The next bar would be the 70 to 79, which there's 7 of those. So this bar is 70 to 79. Next bar is the 60s, 4 of those. What's that? 1, 2, 3, 4, 5, 6. 4 of those. Those are the 60s. And the 50s, there's 1 in the 50s. And there's 4 that are below that. This zone is 0 to 49. So there would be a bar chart. That makes sense? The heights are just the frequencies. There's a bar graph. Good? Easy enough? The heights are just the frequencies. So that's real nice, right? We work, humans, meaning we people, work well. You know, if somebody showed you that and they said, here's how the class did as a whole, that's a lot more helpful. Go, oh, yeah. So a lot of people got A's and B's. Some more got some C's, D's, chunk of F's. You know, you'd have a feel for the group as a whole. That's what a bar chart can do for you. Is that okay? If I flash off of that, I feel like I'm flying along in this class. But you guys never stop me. So you feel free to stop me. Say, Mr. Heron, what's this, what's that? Slow down. All at once. Okay. So let's say 2 people got A's on some quiz or something. 9 got B's, 10 got C's, 3 got D's, 2 got F's. How are you going to show that as a pie chart? Well, should be pretty easy. You just make the percentages, right? So like, so we just got to see which one of these is right. Like A's are what percent? How do we figure out the percentage of people that got A's? What are we going to do to figure out the percentage of people that got A's? Yeah, it's always about total, huh? Percentage is always part over the whole, part of the total. So what's the total number of people who took this thing? Be whatever, 2 plus 9 plus 10. 2 plus 9 plus 10 plus 3 plus 2. 21, 24, 26. 26. So A's percentage would be 2 out of 26. See how I'm coming up with that? 2 out of 26. So just take 2, divide by 26. I don't know. Is that the 7.69? It's probably that. I'm looking at the answers. Probably 7.69%, right? Does that make sense? 0.07. Your calculator would tell you 0.07. You convert to a percentage. That good? And then B's. How many people got B's? 9 out of 26. So that's 30. I'm going to look at 34.62, I bet. Because I'm looking at the answers. And I'm looking at the ones that looks reasonable. So it's more than a third, so it's more than 33. And I looked down and saw it at 34.62. So that must be it, right? So already I think we can pick out the right answer. Isn't it D? Oh, is it D? Yeah, isn't it D? D's the only one that has the right A and the right B, right? C has the right A but the wrong B. B has the right A but the wrong B. A has the wrong A. So, it's T. Done. You can keep going, but why bother? We got our answer. Does that make sense how to do that? Pretty easy on a multiple choice kind of thing to identify the correct pie chart based on the percentages. Just part over whole. Divide by the total number. Good? All right. All right, so this is the statistics stuff. So, all right, let's see. The bar graph, 10-point quiz. So do you understand what that bar chart is saying, first off? Those are the various scores people got. And that's how many people got the various scores. So in other words, a score of 3. How many people got a score of 3 on the quiz thing? 4. Yeah, the 4. Right, same thing for 4 people got a 3, 4 people got a 4. 2 people got a score of 5. Right, I'm just looking at the bars and how high up they go. So 3, 4, 5, right, 2 people got a 5, etc. That makes sense what that bar graph is saying? Now, how many students took the math quiz? I came up with 40 because what did I do? How did I come up with that 40? Do you all see that? I added up the numbers, huh? There's 4 here, 4 here, 2 here, 4 here. What's this one? 13? 13. This one's 5. 5. 3. Is that right? So that's how many in the various categories. I just added those numbers up. So for part A, I just did 4 plus 2 plus 4 plus 13 plus 5 plus 5 plus 3, 10, 17, 27, 30. Wait, I'm getting 30. 8, 10, 27, 30. Oh, 40. It is 40, yeah, 40. We all good? Just add. And what percentage of the students scored 2 points? Well, nobody. Nobody scored 2 points. The lowest score up there is a 3. So that's why this is 0. Right? 0%. Nobody got a score of 2. That was kind of a dumb question. If a grade of 6 or more was needed to pass, what percentage got it? How did I get 75% there? 6 or more. So here's a 6. Here's a 6 or more. 6, 7, 8, 9, 10. How many people got that for part C? So it's right there and above. So that's 4 plus 13 plus 5 plus 5 plus 3. What is that? 17, 27, 30 out. And it's always over the total. Whenever they want percentage, it's divide by the total, huh? Divide by 40. You'll get 0.75, which is 75%. 75% got that score. Good, pretty straight ahead, nothing too fancy. It's just how you display information. We'll get some fancier parts to this chapter, but so far, good. Feel free to stop me. Okay, let me let you look at that for a minute. Can you see that? Let me give you just a minute to think about that chart. Think about that. There's questions. All right, so possible cause of death in population among 18 to 20, so young people. Okay, so cause of death among young people. Is cause of death quantitative or qualitative? Let me explain that. Quantitative means it's a number. Let's just write the word number. It's a number. Whereas qualitative means it's not a number. So that'd be like if somebody said, "How are you feeling today?" 3. That's the wrong kind of answer to that question, right? How are you feeling today is a qualitative question, not a quantitative. There's not a number answer to that kind of a question, right? Whereas if somebody says, "How many cars do you own?" and you said, "Good," then that's again the wrong kind of answer, right? How many cars do you own is a quantity. Well, quantity means number, right? Quality is not a number. Okay, so therefore it's cause of death. If somebody says, "Well, how'd they die?" and you said 3. That's wrong, right? How somebody dies is not a number question. It's a quality question, right? So it's a quality question. Okay, B. Based on the data provided in the pie chart, estimate the number of 18 to 20-year-olds who died in the population studied due to an accident. So how do you figure out the number? I came up with this 8,000 number here. How did I come up with that? Accidents right up here. 40, almost half of those young people that die from an accident. 45% roughly. So how do you figure out how many actual people that is?
The percent of the total?
Yeah, just go with the total, huh? See the capital N right there? Can you see that okay? That's the total. So the total number in the pie chart is 19,500. So that whole pie chart thing is telling you about 19,548 people. That's what it's about. So therefore, if it says accidents happened, 45% of them. So you've got to take the 0.45588. Is that right? Yeah. Change it back into a decimal. Right. Move the decimal back 2 places and multiply by the 19,548. And I guess that's where I got the 8,912. Round to the nearest whole number. Everybody good on that? So it's the percentage, it's the part of the whole circle. 45%, 8,912, just under 9,000. Good. Now the last question C is a little more tricky. Estimate the size of the central angle of the slice representing the category other. So they want an angle. It's kind of weird, right? The other is 21%, right? The other is that. The other is 21.513%, right? Yeah. So what do I do? They want like the angle. You guys know what I mean by angle, right? Like if I open my hands at a certain angle, right? Bigger angle, smaller angle, open the door, big angle, little angle, right? Angle's an amount of opening, right? Remember? Did you take geometry in high school? Or is it kind of weaved in now with math 1, math 2, math 3?
I don't think they've started that yet.
Haven't they?
I think they've already started, but it's getting to that point.
Okay, so geometry is still separate?
For now, yeah.
Did you guys take geometry? Did you like geometry? Was that a good one? Yeah, I didn't. I had a really good algebra teacher in high school. He was real serious and good. And then in between I had geometry, and that guy was terrible. I mean, he just didn't give a hoot about whether we learned anything. He would just kind of come to class and kind of scribble on the board for 5 or 10 minutes and sit down at his desk for the other 50 minutes and just fiddle around with his computer and stuff. Anyway, he didn't seem to care at all, and then, therefore I didn't learn anything. Anyway, so I learned geometry in high school. I learned it all later. But and we're not going to do much geometry in here. So just amount of an opening. Oh, yeah, we've talked about angles because we did the parts of the pies and the things earlier. That's right. That's right. We've been over all this. Yeah. So how much degrees in a whole circle? 360, right? Y'all aware of that one? Why? Anybody ever ask you that? Is that a weird question to ask? I like to know why. I'm a big why guy. So why? I must drove my parents nuts. Why? So why are there 360 degrees in a whole circle? Do you know they just made it up? They absolutely made it up. They just said, They could have started with 100 or 1,000. You know, it's kind of weird they didn't have a more clean number. They just decided that all the way around would be 360, and then everything else came from that. Therefore, halfway around to 180. We talk about turning a 180 halfway around. That's half of 360, right? Or a right angle, which is a fourth of all the way around, is 90, right? That all comes from all the way around to 360, and they just made up the 360. They really did. They just said, hey, we're going to call the whole circle 360, and then everything else came from that. Why did they call the whole circle 360? They could have said that, let's make it a nice even 1,000. Then, halfway around would be 500, quarter would be, a right angle would be then what? 250, right? And, they could have done that, but they decided all the way around is 360. And think about what they were doing. They first used angles in history. I'll give you a little history. Remember, I want to be history teachers. Like, give me 1 minute of history here. They first used angles for astronomy on the ocean. They would look at the stars and note their angle heading, and they would figure out their heading based on angles for navigating ships. That's when angles were first used historically. So, what were they thinking all the way around being 360? What was their experience all the way around was close to 360, more precisely 365? What happens every 365? What's that? Yeah, we circle the sun. Right? We circle the sun every 365 days, approximately. Not exactly. That's why we have leap year. And did you know leap year doesn't really happen? Leap year is when? Leap year is every 4th year. But did you know then every 100th year, which should be 25 fourths, it doesn't happen. Did you know that? Of course, we haven't been around, any of us, more than 100 years. But that's true. You can go to Google and stuff. It's a constant, because we don't go around the sun exactly 365, or 365 and a fourth, exactly, so that every 4 years will exactly handle it. No. It's an ongoing decimal. So they keep tinkering with it. So every 4 years a leap year, because we're not, to get us right back on that. But then every 25th, 4th year, 100th year, you don't take the leap year. You go 8 years with no leap year. But then every 1,000th year, which should be 10 hundredths, when you're supposed to not take the leap year, you take it again. And they have all these, if you go into Google, you could figure all that out. But anyway, there's these constant shifts. And that's because we go around the sun, not exactly 365. Anyway, back in the day when they first were doing angles, they thought their estimate was we went around the sun about 360 days. That was as good as they could estimate it. And so that's where it came up. They just said, hey, let's call all the way around 360. So they just made that up. So that's where angles come from. 360s all the way around. It's totally made up. So when they say to me, hey, find out how big that green angle is there. That opening, like right, I don't know if green on green works. I guess it works okay. So how big is that opening, that green angle? Well, it's 21%, 21.513% of all the way around. Of all the way around. Of all the way around. What is of always in math? Multiply. So just turn this into a decimal, 0.21513, right? You always turn percentages into decimal. Of times all the way around. How many degrees in all the way around? Well, 360. It's supposed to be a 3, but it looks funny. So that's all you do. You just multiply by 360. You just make it a decimal and multiply by 360. Because that portion, it's that portion of all the way around. It's that portion of a full circle, isn't it? It's 21% of a full circle. So it's just times. So I guess that comes out 77 degrees. Rounded to the nearest whole number. Does that make sense how you do that? So if they ask you what an angle is, just take the decimal times 360. Because 360 is a full circle, as they made it up. Good. And I leave this then. So pie charts, pretty straight ahead. All right. Pie chart represents breakdown of the 2.9 trillion federal budget of a country's last fiscal year. Note, 1 trillion equals 1,000 billion. Use the pie chart to complete parts A and B below. A, estimate how much money the federal government spent on last year's defense. Okay. So what do you think? How do we figure out, I already got an answer there, but how do I come up with that? How do we figure out how much they spent on defense? So it's right, I mean, the percentage is right there. 24.6%. So what do you do with that? 24.6%. So we know you move the decimal back. So 0.246. But then what? 0.246 what? Do you understand what they're saying up here? Well, we got to go times the whole, don't we? Because it's 24.6% of the whole budget. You with me on that? Percentages are always a percentage of a whole, aren't they? So, what are we going to do? 0.246 times the whole. What's the whole? What's the whole budget? 2.9 trillion. Yeah. So 0.246 times 2.9 trillion. You guys got that on your calculator? I think it's going to be 0.713, isn't it? 0.713, is that what it comes out to be? Now, why did I answer 713 billion? There's no decimal there. And yet we're getting 0.713. It has to do with this. Do you understand that statement? You ever read charts with big numbers? They do that all the time. It's pretty common. 1 trillion is 1,000 billion. Do you ever thought about the fact that whenever you go up, like say let's write the number, I don't know, there's 1,000, right? There's 1,000. If I add 3 zeros, what number is that now? That's 1,000,000, isn't it? Whenever you add 3 zeros to a number, what did you just multiply it by? If I take 5 and I add 3 zeros to it, it becomes 5,000. So what did I just multiply that 5 by? 5 times what is 5,000? 1,000, huh? You with me on that? So whenever you add 3 zeros, you're really multiplying it by 1,000, huh? So therefore, if I take the number 1,000, like it was originally, and then I add 3 zeros, I make it 1,000,000, and that means I multiplied it by 1,000. In other words, 1,000 thousands is 1,000,000. Whenever you take 1,000 of anything, that kicks you into the next number category. That's what I mean to say. Because it adds 3 zeros and jumps you to the next spot. So if I added through, that's 1,000,000 right now, right? This is 1,000,000. If I add 3 zeros again, so I take 6 zeros, Whoops, I'm not doing very good. Here, let me try again. If I take the 6 zeros, I'll add them with different colors if that helps. So there's a million again. And now if I add 3 more zeros, what's that number now? That's a billion, huh? Right, so whenever you add 3 numbers, you go to the next, million, billion, and then if I add 3 more zeros, let me do that one more time. I think that's about as far as I'm going to want to go. Add 3 more, so let me go back to the, oh, come on, what's the problem? Okay, add 3, so now I'm going to add 3 more zeros, 1, 2, 3. What's that number now? Trillion, isn't it? By 2 trillion, try, it's going up. Next will be quadrillion, and on you go. So anytime you add 3 zeros, you jump to the next number category, huh? Million, billion, trillion, quadrillion, on you go. By adding 3 zeros, huh? And that is timesing by 1,000. So that's what they mean up here. A trillion is 1,000 billion. It's take a billion, add 3 zeros. Which is what we did right here. I took a billion, there's a billion right there, and I added 3 zeros to the back, and it became a trillion. So they're just making us realize that. So whenever you add 3 zeros to the back of a number, it jumps into the next number category. A million becomes billion, billion becomes trillion, trillion becomes quadrillion. So basically, so what does that mean a million is? If you have $1 million, you have 1,000 $1,000 bills. That's what that means. It's like having 1,000. And if you're a billionaire, like the richest people in the world right now, Bill Gates and that other guy, are billionaires, which means they have what? 1 million 1,000 times. That's a lot, huh? They have $1 million 1,000 times over. Right? That's what it always means to be in the next category. So to be a billion, you got to have 1,000 millions. So that's what that means. So what does all that mean about reading? That's not just silly stuff or whatever. I'm not just doing that to talk about money. I don't really care about that much, but it helps you to read charts. It helps you to read big number charts. They do that all the time when you read these kind of charts. So a trillion is 1,000 billion. So when you look at this right here and you say, okay, 2.9 trillion is the total budget. You take that 2.9, and if you multiply it by that's 2.9 trillion. That's move the decimal. Now, I shouldn't have been saying add 3 zeros every time. When you add 3 zeros, I should be saying it this way. When you multiply by 1,000, right? That could add 3 zeros to the back, or that could move the decimal 3 places. It's the same. Well, it's not the same thing. Do you know what I mean? I'm kind of stuttering all over the place. Am I making any sense here? So if you take 2.9 trillion and you move that decimal 3 places to the right, 1, 2, 3. So that'll actually add 2 zeros to the back because the first jump had to get past the 9. So 2900 billion. Does that make sense? 2900 billion is the same as 2.9 trillion. That's what's going on there. Right? Because 2,000 billion is 2 trillion. How about that? That might be the easiest way to hear it. Right? Because remember, 1,000 of anything is one of the next category. So 1,000 million's a trillion. No, I mean a billion. And 1,000 billion's a trillion. So 1,000 of anything kicks you into the next category. So 2,000 billion is really 2 trillion. Make sense? So what's all that mean? Well, they want the answer right here. Notice the format they want the answer in. Billion. They want it in billion. Therefore, I should not use 2.9. That is the whole, but I should use 2,900 billion. So you do that in your calculator and you'll get the, what is it, 713 over here? Yeah, 713. 713 billion. Does that make sense? So basically, don't use the 2.9, use the 2,900 for the whole in all your calculations because they're asking you to give the answer in billions. So 1,000 billions is 1 trillion. 1,000 of any category kicks you into the next. All right, that was a lot of explanation for all that. But that is valuable. It's used all the time when you read big number charts. Okay, so 1,000 of anything kicks you into the next category. 1,000 thousands is a million. 1,000 millions is a billion. 1,000 billions is a trillion. Okay, so Okay, so part B, calculate the size of the central angle for each slice of the pie chart. All right, so how are we going to do central angles again? What do we do? Let's start with defense. So defense, 20, so we make it a decimal, 0.246, right? Change from a percentage to a decimal, 0.246, and then what do I do with 0.246? To find an angle. They want me to find an angle. By 360, yeah, right? You just multiply by 360 degrees, and whatever that comes out, that's your answer. It's, I don't know, it's like a fourth, that's like 90, just under 90, 89 something, or 88. Shine, you got it?
88.56.
88.56, thank you. I don't know how far they want us to round, what do they say? Oh, nearest degree. So this one, I guess this one 89 then, so I'll just round that to 89. 89 degrees. Is that good on that? That makes sense. So all the rest are the same. Just multiply their percentage, like for the next one for Social Security. You would just take Social Security was 20.9, so I'll make it 0.20, and I just move the decimal back 2 places, times 360. 78, so 79, 80, something like that. I think. Anybody else getting that? I think it's 78, 79, 80. Might be 81. I don't know.
75, 24. For the red one?
Yeah.
75.24.
Oh, okay. I'm thinking wrong. What do you guys, Cheyenne, again? I'm sorry.
75.24.
So we'll just round to 75. Thank you. And on you go. Is that good? That makes sense? Just again, for angles, just multiply by 360, because that's the whole circle, as they made it up. And that's the first section. Let's move on.